If I got locked away and we lost.
Hey guys, and welcome to our Earth and Rock study video for our test upcoming later this week. You know, I have a ton of resources I want to get to. I am going to send you over to a screenshot of my computer, and we're kind of just have our study session on a PowerPoint tonight, and I'm going to stop, and you're going to be able to interact with it. So make sure you have a pencil or a pen available along with some paper, and that will help you as well. In addition to what I'm about to show you in our study video, I do have my science book right here in front of me because I think there are some valuable resources that you can use right here, right now. So to begin with, I'm just going to give you some pages and some areas that you may want to check out in case you have a few areas that maybe you're still a little confused about within the unit. That would include page 378 in your science textbook that's going to talk about erosion and deposition and weathering, all of those concepts, as well as page 379 and flipping it over to 380 and 381. That's going to talk about erosion, deposition, all of those great things. And then if you flip on through a little further, you're going to get to some pages that talk a little bit about Earth and the plate movement. So if you go to page 400, I thought that that was a pretty good page to check out for the different layers of the Earth, as well as some plate movements talking about earthquakes as well. And then to get over to the rock cycle, there are two pages I really think are pretty valuable. Number one, page 438. And you may want to pause here, either write these down or check them out. 438 gives you statements that you then can write under either igneous, sedimentary, or metamorphic, which is something we're going to do in the study video in a bit, and it's just a really great strategy to practice. And then page 440 and 441 really go into sedimentary, igneous, and metamorphic rock types, which you may want to check out as well. And then finally, the other resources that I wanted to show you was actually the practice test. It's actually pretty good. It starts on page 448. Okay, it's going to address different mineral properties and different things like that, and it goes to page 450. Okay, so it's actually really good, guys, and you may want to check it out. So now you are going to lose my facial part of the video, and we are going to go over to just a screenshot, and I'm just going to be narrating it as we go because I have a ton of different diagrams and things that I want you to check out. Make sure that you pause and stop where you think you need to, because I really want you guys to be strong with this area of science. I think that we've had a great unit, and I think that you've learned a lot, so I really want you to demonstrate that on your assessment coming up later this week. So now I'm going to send you right over to the screenshot. Okay guys, we're going to start off today with our review of the layers of the Earth. So the first very basic thing that you need to make sure you have down would include the actual names of the layers of the Earth. And here I have included a diagram to kind of help us study that. You know, you could do one of two things with this. You might want to actually put this onto a sheet of paper, draw it out, okay, draw the different layers. You can get a total of 20 house points if you complete the entire study video. At the end. So if you show me all of your proof of work and different things like that, then we'll be good to go. Then I'm going to take this cover off, and you can kind of compare your work to what I have for the different layers. Okay. So let's see what you have. As soon as I move my cover off, you should have the inner core, okay, and then the outer core, and then the mantle is this orange, dark orange part, and then the crust. So I have a few facts that I want you guys to think about right now, and those would include what are each of these layers made of, okay? That's really important that we get that down. I'm actually going to add some text here as we go. So what is the crust made of? What is the mantle made of? What is the outer core made of? And what is the inner core made of? Those are four very important things. Okay, so write those down on your paper just like I just typed on the screen. Okay, and then the crust is obviously a rocky and I'm going to say not very deep part of the Earth. Okay, remember we said in the oceans, ocean crust is only about 6 miles deep. Okay, that's about 25 miles deep here on land. Okay, and then you'd get down into the mantle. The mantle is obviously molten rock. Okay, we have something we call magma, as we talked about, and it is currently churning. Okay, due to the convection currents in the because of the thermal energy, okay, and that's because of the heat. Remember we said, and I showed you that video, that the magma is just churning in these circles in the mantle because of that, okay. The outer core it's not totally solid, remember we talked about, so it's kind of melted iron and other things like that, and then the inner core is a more solid mass because it is in the middle, and if you think about all the pressure that's pushing down on it, it would be solid metals and different things like that. So those are the characteristics you want to have down for the layers of the Earth. Okay, about how old is Earth? Do scientists believe? Yes, it is 4.6 billion years old. You're definitely going to want to write that down 100 times and make sure you know that left and right. Now, there is evidence as to why Earth is 4.6 billion years old, and that would deal with the fossils like we've talked about in class. Okay, then we move on to the 3 different plate boundaries, because we know that Earth up here is broken into how many major plates, guys? Yes, 7. And remember, we used an orange in class, okay, and we peeled it, and then you guys put it back together with toothpicks, and we know that the crust is broken into some major plates, okay? Those major plates, let me go ahead and erase that. Here's a good image of that. You can kind of see the breakage there. And we need to talk about the 3 different boundaries, okay? So what I'm going to do beside each of these is type the name. But what I'd like you to do is just draw them with arrows, okay? So before I actually type in the names, I want you to think about what they are actually called. Okay, the names of each of the boundaries. So the first one, where the 2 plates are crashing in together, would be called a convergent boundary. Oop. And then the boundary where the plates are moving away from each other would be a divergent boundary. And remember, if we just know the words convergent and divergent, we know that those, if we know the meaning of those, then that should make a lot of sense to us. And then the final one would be a transform boundary. Okay. Or we could also call it a strike-slip boundary. Okay, so convergent boundary, divergent boundary, transform or strike-slip boundary. So it's very important that we have those 3 boundary types down, but then you have to go a little deeper and tell me what would form here. Okay, when we have 2 plates coming together, what could form there? When we have 2 plates moving apart, what could form there? When we have 2 plates striking and slipping each other, what could form there? And to help you with that, I actually found a really cool video I'm going to take us over to. Let me actually just hit present mode so that you can check this out, guys. So that would be a convergent boundary, scholars. The plates are coming together, forming mountains. So the Himalayas are one real-life example of a convergent boundary. The mountain range formed when the 2 plates collided. They converged. So convergent comes together, and now we have divergent. Remember that mid-ocean ridge out in the Atlantic Ocean. The plates are pulling away from each other. And that is where the new crust is forming, okay? Typically at the mid-ocean ridge, because literally magma is just filling in that hole where the plates are moving away from each other. There's a good visual coming up in the next part of this video, so check it out. So look at all that new crust forming at the mid-ocean ridge when the plates move away from each other. And here you also have, guys, a convergent boundary just due to the fact that the plates are sliding underneath the other plate. They're still converging. And that is where you can have a trench form, okay? So convergent boundaries could form a mountain, but also a trench. And that's a good example of that. And then finally, the transform boundary is where we find those earthquakes. It's where they're striking and slipping each other. Okay, guys, so I thought that that was a really great visual of all of the different plate boundaries. And let me work on reloading that PowerPoint for us so that we can get back to our slide. Okay, so we have convergent boundaries where the plates are hitting into each other. They're coming together. We have divergent boundaries where they're going away from each other. And transform boundaries or strike-slip is where they're rubbing against each other. Okay, now the big thing that I want you guys to do is tell me a real-life geological feature that you could see forming at each of those. So a convergent boundary, you could have two things. You could have a mountain or a trench, because remember, sometimes that one plate is going to go down underneath the other one, and right here you would have a trench form. Okay, so you could have a mountain or trench form there. The Himalayas are one such example of a real-life convergent boundary. Okay, another such example that you may see at the divergent boundary would be the mid-ocean ridge or a rift, okay, and this is where new crust is formed. Because think about it, guys. If you have two plates going away from each other, what would be left right here? Well, the magma from the mantle would come up and fill this whole area in right here, okay? So that is why you have new crust forming at a mid-ocean ridge or the divergent boundary. And finally, a real-life example of the strike-slip boundary, the transform boundary, obviously would be an earthquake, okay? And we talked about the San Andreas Fault being one such example there, okay? So I am going to flash characteristics up onto the screen right now, and I would like you just to either write them down or say them out loud. What type of boundary would each of these fit into? And remember, our choices are convergent boundaries, divergent boundaries, and also transform or strike-slip boundaries. So these are formed when plates move together. Correct, that is a convergent boundary. Very good, okay? Let's go on to the next one. Mid-ocean ridges are created by these plate boundaries. Think about it. Yes, you are right. Those are divergent boundaries. Just remember, because the plates are going away from each other. And what happens here? Well, a little bit comes up. And remember the graham cracker? You guys were all like, whoa, whenever the icing kind of stuck up like that. And that is where new crust is formed, okay? So I cannot say that enough. New crust is formed right here, okay? How about these are formed when plates move apart? Okay, yes, that would be divergent boundaries as well. And what is formed here? Well, that would be a rift. Okay. And then also known as strike slip or sliding boundaries. Think about it. And yes, those are transform boundaries. Okay, that's where you would find, that was where you would find your earthquakes. How about these are formed when plates slide past each other? Those would be transform boundaries, and when they slide past each other, you get what is known as an earthquake. Okay, and finally, ocean trenches are created by these plate boundaries. Those would be convergent, remember, only because sometimes you have convergent boundaries that look a little something like this. Okay, and when you have one, they're both coming together, but then you get this little bit of a hole right here, which would create a trench in the ocean. Okay, so now I'm going to move us on to the talk of minerals versus rocks. And the first thing that I want to do is actually differentiate between the two. Okay, now you guys were all kind of amazed whenever we talked about the fact that minerals and rocks are totally formed naturally in the earth. No humans have any impact on them whatsoever. Okay, so they're naturally formed. Okay, typically, you know, in the earth. Okay, that would be the mineral. Okay, and the mineral would be it would be pure because it doesn't have anything else mixed with it, right? It's just one set mineral. Now a rock is simply when, okay, and let me take my font down a little bit there for you guys. Think about what we talked about a rock would be and what characteristics it would fall under, because that may help you to think as well. But it is also naturally formed. Okay, it's a solid. And it's made up of one or more minerals. Okay, so when you take a bunch of different minerals, you take a mineral and put them together, you get a rock. Okay, all of them are naturally formed, and that's very important to know. Humans have no impact on how rocks or minerals happen to be formed. Okay. So we are now going to talk a little bit about the mineral properties. Now remember that Brady told us, he gave us a good synonym, or a word that's similar to properties, and that would be characteristics. Okay, this is how scientists test minerals in order to identify them. Remember, I showed you there are tons of different colors and types of quartz, but whenever you test a streak of all of the different quartz, it has the same color show up on the streak pad. Even if one of the quartz is pink and one of them is white, they still have the same color streak. So scientists are able to use those characteristics, those properties, to figure out what type of mineral that they have. Okay, so the different mineral properties that we could have, go ahead and try to list them down right now. Think back to whenever you tested not only the minerals we had in class during Jurassic World, but also the minerals that the Mineral Man brought in. Think about all those minerals that you tested, okay, because that will be very helpful to help you link that understanding together. So a few things that you tested would be luster, okay, and that would be the shine. Was it glassy, metallic, dull? Okay, how about the hardness, okay, based on Mohs hardness scale, okay, Mr. Moh, okay, and his hardness scale, a 1, the softest mineral known to man, guys, was talc. And a 10, the hardest mineral known to man, is diamond that we cannot break. Okay, you could also test the color. You just look at the color. The streak, that's when we actually use the streak plate. And also the cleavage, you know, the fracture. How does it break? Okay. So these are the properties tested by scientists when trying to identify different rocks and minerals in nature. Okay, so now what I'm going to do is put a characteristic up on the screen, and I would like you to tell me if it was a characteristic of a sedimentary, a metamorphic, or an igneous rock. Okay, here we go. Sometimes they include a picture. Okay, write them down on your paper so that you can get all your house points for the work that you turn in. Here we go. Let's start with the first one. Magma and lava becomes this type of rock. This is my favorite. Yes, the igneous rock. Very good. Let's go to the next one. Compaction and cementing form this kind of rock. Okay, wonder if anyone saw this driving down 95. I said look at the side of the hills and you'll see this. That would be sedimentary rock. Very good. Let's move on to the next one. Weathering, erosion, and deposition can have an impact and actually help to form this type of rock. That would be sedimentary as well. Very good. Sediments pressured together over hundreds of years. What type of rock would that be, guys? That also would be a sedimentary rock. Very good. How about obsidian is one example of this type of rock? Think about it. Yes, that would be an igneous rock, and obsidian is formed specifically in the ocean whenever lava or magma makes its way into the ocean. It cools very quickly, and you get the igneous rock obsidian. How about conglomerate is one example of this type of rock. And you know, using your inferencing skills, if you look at that rock and you think about the three types of rocks, sedimentary, igneous, and metamorphic, and you have tons of all these tiny pebbles pressed together, what type of rock might that be? Yes, that would be sedimentary. Okay, all that's required to form a sedimentary rock is pressure and sediments pressed together over thousands of years. How about forms when rock is placed under great pressure and including heat? Okay, so heat and pressure, that would be metamorphic. Okay, so essentially with the metamorphic rock, you know, I said it was kind of in between a sedimentary and an igneous because it requires the different characteristics of each. Okay, it has all that pressure from the layers pressing down on top of it, but it also has heat from the Earth's mantle, which is also significant as well. Okay, moving along even further, marble is one example of this type of rock. Very good. That would be metamorphic. And you know, when I was making this presentation, guys, something that really came to mind with the metamorphic rock is, if you look here, it requires heat and it requires pressure. Remember, I said it was in between sedimentary and igneous. And if you look at this, you can see these little black lines here. You can kind of see how the heat and pressure kind of impacted it. If you remember what we did with the crayons is we melted them a little bit, but not the whole way. And then we pressed down on it in wax paper to form the metamorphic rock. So that kind of did a cool little number there. Marble would be one example of metamorphic rock. How about this type of rock may contain fossils? Just think about the characteristics of each. That would be sedimentary, okay, as well. So make sure you have those different characteristics down. I shared that page in the book with you at the beginning of this study video. That will definitely help you as well in that department right there. So with the rock cycle, let me give you a little bit of help with this, because I think as soon as you think of it in this way, it will not be as hard, okay? Here's what you need to do. Before I even put the rock cycle imagery up here, okay, I'm going to put one name of a rock, and that is igneous rock. You need to think to yourself, how does igneous rock form? Okay, what are the characteristics that require it to form? Okay, I said if you know that, then you know the entire rock cycle. Okay, so it would be melted magma and lava cooling. Okay, that would form an igneous rock. So now let me take you over to the rock cycle to show you how that connects. Okay, so if you can for a second, look at the igneous rock here. Okay, and then look at the other characteristics here. We have magma. So when magma, and follow the arrow, cools, you get an igneous rock. When an igneous rock melts into magma, then you can get something else, which would be partially metamorphic. Okay, so when magma cools, you get igneous. Follow the arrows just like that. Okay, let's do that with one more to kind of get that down in our brains as well. Let's take a sedimentary rock, for instance. What does it take for a sedimentary rock to form? Okay, so it takes weathering to wear down rocks into fine grains of sediment, and then erosion to carry them somewhere, okay, which would be the deposition of the rock, and then pressure over thousands of years. Okay, so let me just bold the important characteristics there. So we have sediment, and we have weathering, and we also have erosion, and then we have pressure. Okay, so those are the things required to make a sedimentary rock. So if I had an igneous rock, how would an igneous rock become a sedimentary rock? Well, let's think about that for a second. We would have to have, and follow me here. So I have an igneous rock. We would have it weathered, okay, and then it would form sediment. And then that sediment would be compacted together with pressure, and we'd have a sedimentary rock. Okay? And the same thing would go for a metamorphic rock. If the metamorphic rock was weathered into sediments and then compacted, you would get a sedimentary rock. So how does a sedimentary rock form? It just requires pressure over thousands of years. It doesn't require a bit of heat. Okay? And let me do that one more time, just so that this comes down in your mind. I know you're probably saying, Mr. Reichard, you have to be kidding me, but we're going to do it anyway. Metamorphic rock. Oop. Metamorphic rock. There we go. Sorry about the spelling. And then we're, how does a metamorphic rock form, guys? Heat and pressure, right? Those are the two words that you need to know. Heat and pressure together, metamorphic rock, kind of in between sedimentary and igneous. So then I come back to my rock cycle and I say, okay, I have myself a sedimentary rock. How in the world can I turn a sedimentary rock into a metamorphic rock at any given time over thousands of years? We wouldn't be able to see it, but our grandchildren's grandchildren might be able to see that. So a sedimentary rock would have to have heat and pressure, so the rock would probably melt a little bit, and then with pressure, you would get a metamorphic rock. How would an igneous rock become a metamorphic rock? With heat and pressure, would become a metamorphic rock. So look for a second, okay, at the three types of rock, and look at the arrows that come into that rock. Those are the characteristics. So an igneous rock requires cooling of magma. A sedimentary rock requires weathering and compaction, and a metamorphic rock requires heat and pressure. Okay? Remember how I said the rock cycle looks so incredibly confusing, but in all reality, it isn't whatsoever. Okay? If you know how is a sedimentary rock formed, how is an igneous rock formed, how is a metamorphic rock formed, then you have it all down. And one last final diagram I want you to check out would be right here. Okay? It kind of adds in all of those great pictures that we've been looking at in visuals. Okay, and once again, you see it is a circle, it is a cycle, but it's kind of more of a web as well because it goes in all different directions. Because any rock can become any other type of rock with the correct conditions. Okay, so sedimentary rocks would have to require weathering and erosion of sediments, and then you get sedimentary. Heat and pressure would cause a metamorphic rock, and finally, melting of magma and the cooling would then form igneous. Okay, always look when the arrows are going into the rock, that means that's a characteristic that forms the rock. Okay, so that concludes our study video, Room 21 Rock Stars, of this unit. It is a pretty packed one, and you do have Tuesday off of school, so that would be a prime time to study this at home. Okay, if you bring in all of your work from the study video, you can get yourself 20 house points this week for your effective effort in putting forth some amazing stuff to prepare for this particular assessment. And that concludes this study video.